Let us start our class. So from your previous lecture, do you have any confusion? Do you have any confusion regarding the overtaking side distance and overtaking zones? Okay. So in the geometric design element, the first portion was side distance element. So we have completed the side distance element. So now we will start that design of horizontal alignment. Now in the horizontal alignment design, there are different components. Okay, so in the horizontal component design, these components are design speed, horizontal curve, super elevation, type and length of transition curves, widenings of pavement on curves, and setback distance. So in this class, we will discuss about the design speed, horizontal curve, and super elevation. These three things will be covered in this class. Now, design speed is the speed which is considered for the design purpose. Now, before the design speed consideration, this design speed varies with the different terrain classification. So, in our previous classes also, we have discussed about different terrain condition like plain terrain, rolling terrain, mountainous terrain, and steep terrain. Now, basically, what are these terrain indicate? Basically, this terrain indicate the geographical condition of a area. Now, if the cross slope of that area is 0 to 10%, in that case, it is called as plain terrain. Now, if it is 10 to 25%, then it is rolling terrain. For mountainous terrain, this cross slope is 25 to 60%, and for the steep, it is greater than 60%. So these are the different terrain classification. Now your design speed will be varying upon the this cross slope or this terrain classification. So for example, these are the design speed, that is IRC recommended design speed on highways. Okay, so these are the different road classification, and based on the road classification and based on the terrain condition, there are different type of speeds. Okay, that is defined. Now another thing you can notice that here, suppose for the plain terrain, two values of the speed for the same highway is mentioned. One is ruling and one is minimum. Okay, minimum means that is the minimum speed which you have to provide it, and ruling means that is the desirable speed you want to provide over there. Okay, these are the different speed consideration, design speed consideration for different type of highways based on the terrain conditions. Now coming to the next portion, horizontal curve. So a horizontal highway curve is a curve in plane to provide change in direction to the central line of the road. Change in direction means suppose a straight road is there. Now suddenly you need to change the direction. In that case, the horizontal curves will enable the driver to change the direction. That is a horizontal curve. Basically, that enables the alignment to change the direction. Now, when a vehicle traverses a horizontal curve, that is when a vehicle moves through a horizontal curve, the centrifugal force act outward, horizontally outward through the center of gravity of the vehicle. You know about the centrifugal force, that is the force acting outward whenever a object is moving in a circular motion. Okay, now this centrifugal force is given by the equation, that is the equation for the centrifugal force, that is P, where it is centrifugal force equal to W V square divided by G into R, where W is the weight of the vehicle in kg, V is speed of the vehicle in meter per second, G is gravitational acceleration, and R is radius of the circular curve in meter. So this is the equation for the centrifugal force. Now this, from this equation, the ratio P by W is called centrifugal ratio. Okay, this is called P by W is called centrifugal ratio. So your centrifugal ratio P by W is equal to V square by GR. Now, the centrifugal force acting on a vehicle negotiating a horizontal curve has two effects. Two effects means whenever a vehicle tries to overtake or tries to overcome a horizontal curve, in that case, the vehicle experience two type of effects because of the centrifugal force. So one effect is overturning effect, and another one is transverse skidding effect. Overturning effect means there is a tendency to overturn the vehicle, okay, outwards above the outer wheels because of the centrifugal force. And transverse skidding effect is tendency to skid in the lateral direction outwards, okay, because of the centrifugal force. Now let us discuss about this overturning effect and transverse skidding effect. So suppose this is the vehicle. Here these are the two tires of the vehicle, A and B. These are the position of the tires. Suppose it will act as a reaction. So here W1, if the total weight of the vehicle is W, in that case, in that two support condition, here load would be W by 2 and W by 2. Suppose this CG is, that is center of gravity, is at a height of h from the ground. Okay, now taking the moment of the force with respect to the outer wheel when the vehicle is just about to overturn, that would be, that is the P. You are taking moment about the outer wheel, so P into H equal to W into B by 2. Okay, if you're taking the moment about the outer wheel, so P into H equal to W into B by 2. So basically that is B by 2. Okay, so this is acting outwards. Now this means that there is a danger of overturning when the centrifugal ratio, that is P by W or V square by GR, attains a value of V by 2H. So from this that moment calculation, you got P into H equal to W by 2. So therefore P by W equal to V by 2H. So P by W is your centrifugal ratio. So whenever your centrifugal ratio is equal to B by 2H, a value of B by 2H, in that case overturning of the vehicle happens. Okay, in that case only overturning of the vehicle happens. Now let us consider about the transverse skidding effect. What affect the transverse skidding effect? Okay, so for the transverse skidding effect, wait a minute. Okay. For the transverse skidding effect, similarly, you have to consider the things. Suppose this is the vehicle, this is the centrifugal force, this is A and this is B. Now, whenever a vehicle is over there, in that case, some frictional force will be acting. Now, whenever this vehicle is going through a horizontal curve, so if this is the direction of the centrifugal force, that is P, in that case, frictional force, the direction of the frictional force would be in the opposite direction. Okay, so direction of the frictional force would be in the opposite direction. So here frictional force would be, here it is A, FA, and here it would be FB. Now as this is the outer wheels, in that case the pressure intensity over here would be slightly more than the inner wheels. Now, as frictional force equal to Fa, and if your frictional coefficient is small f, in that case, for A, you can write down Fa equal to F into Ra, where Ra is the reaction force at A, and here it would be Fb, that is F coefficient of friction into Rb. Rb is the reaction force at B. Okay. Now, this transverse skid resistance is given by P equal to Fa plus Fp. Basically, this force is resisted by the frictional force at Fa and Rb. Okay, so this is your centrifugal force which is acting outwards. This centrifugal force is resisted by your RA and RB. Okay, so you can directly write down P equal to Fa, that would be suffix A, plus Fb, that is F into RA plus RB. Now RA plus RB is total weight of the vehicle, that is W. So you can write down P equal to F into W. Now one thing you can notice, so here P by W is equal to F. So from this thing, you can write that whenever your centrifugal ratio, that is P by W, is equivalent to coefficient of the friction, in that case only that transverse skidding effect will happen. Okay, just a minute. So, in other words, when the centrifugal ratio attains a value equal to the coefficient of lateral friction, there is a danger of lateral skidding. So whenever a vehicle is moving through a horizontal curve, in that case, because of the centrifugal force, there are two type of effects which a vehicle can experience. So first effect is overturning effect, and second one is transverse skidding effect. Now, when the overturning effect will happen, when your centrifugal ratio is equivalent to B by 2H. Okay, and how we have calculated this? We have calculated by taking the moment about the outer wheels. Okay, now when the transverse skidding effect will happen, transverse skidding effect will happen when your centrifugal ratio is equivalent to coefficient of friction. Okay, now to counteract this overturning effect and transverse skidding effect, your super elevation is provided. Okay, centrifugal force, and to reduce the tendency of the vehicle to overturn and skid, the outer edge, that is the outer portion, outer edge of the pavement is raised with respect to the inner edge. Okay, with respect to the inner edge, thus providing a transverse slope throughout the length of the horizontal curve. Now, this transverse inclination to the pavement surface is known as super elevation. So basically, see, if it was horizontal, in that case, centrifugal force would be acting upon this direction, in the outward direction. So to minimize the effect of the centrifugal force, what you have to do, you have to raise the outward surface with respect to the inner one. So by doing so, basically what will happen? Basically, in that case, the effect of the centrifugal force would be minimized, because in that case, the centrifugal force will not acting in this direction. It will divided into the components, and different components will be counteract by the super elevation. Now let us discuss this by analysis of the super elevation. So if we consider this, see here it is P. So here this P force would be two component. One is horizontal component and another one would be vertical component. So the horizontal component, suppose this angle is theta, so it would be theta, and here it would be also theta. So your horizontal component would be suppose this one. Okay. So this is your P cos theta. Okay. So this is your P cos theta, and here in that direction another force would be there, that would be P sin theta. So similarly for the W also two component would be there, that is W cos theta, and here it would be W cos theta, and here in that direction another force would be there, W sin theta. Okay, W sin theta. Now see here your P cos theta, that force, okay, that is the component of the centrifugal force, it would be counteract by W sin theta. Okay, it would be counteract by the W sin theta plus the frictional resistance offered between the tire or wheel and the road surface, so that is Fa into Fa plus Fb. Okay, so your P cos theta would be, so your P cos theta would be equal to W sin theta plus Fa plus Fb. Okay, so Fa plus Fb. So if you can fraction this out, that is P cos theta equal to W sin theta plus for the Fa it would be F into Ra plus F into Rb. So ultimately you can write down P cos theta equal to W sin theta plus F into Ra plus Rb. Now another thing you have to notice, that here Ra plus Rb, that is the reaction force here, Ra plus Rb, that is the total reaction force, that would be equivalent to the total downward force acting over there. So in the previous case our Ra plus Rb was simply W because that force was vertical, but here it is in inclination, so you need to consider all the components. So in the downward direction the components acting are, see here P one force would be there, that is P sin theta, that would be also acting over there. That is P sin theta, and another force would be acting, that is the component of W, that is W cos theta. Okay, so these two force would be acting in this direction only along with this line. Okay, so your total Ra plus Rb equal to here W cos theta plus P sin theta, W cos theta plus P sin theta. So you can arrange this, that is P cos theta minus F P sin theta equal to W sin theta plus FW cos theta. So P cos theta minus F sin theta equal to W sin theta plus F cos theta. So divide this by W cos theta. You are just rearranging all this formula. That is dividing by W cos theta, you will get P by W into 1 minus F tan theta, okay, equal to tan theta plus F, or centrifugal ratio P by W equal to tan theta plus F divided by 1 minus F tan theta. Now this tan theta is basically the super elevation provided over there. Okay, super elevation provided over there. Now one thing you need to remember, the value of coefficient of lateral friction F is taken as 0.15, and tan theta, that is super elevation, seldom exceed 7%. So basically this is the maximum value for the super elevation, 7% or 0.07. So if we multiply 0.15 to 0.07, it would be very small. So 1 minus that one would be like 0.99. So which is basically approximately equal to 1. So for that reason, you can just omit this portion. So it would be centrifugal ratio P by W equal to tan theta plus F. You just consider only this portion. For the calculation, easiness in the calculation, you just omit this portion, that is the down portion, 1 minus F tan theta. Because it would be equivalent to 1, so there is no need to consider about this. So your centrifugal ratio P by W would be F plus tan theta. Here tan theta is generally E. So E plus F equal to P by W, and you know P by W equal to V square by GR. So therefore the general equation for the design of the super elevation is given by E plus F equal to V square by GR. So this is the general equation for the super elevation when the V is in meter per second. But if the V is given in kilometer per hour, so you can do two things. First, you can convert the speed into meter per second, or you can directly use this formula, okay, to use V as kilometer per hour. Now G is the gravitational acceleration and the value is 9.81 meter per second square. So this is all about the super elevation. Now, maximum super elevation. So, maximum super elevation, this is very much important in different exams. This question has been asked in different exams, competitive exams. So, maximum super elevation, as I have discussed earlier, for the plain and rolling terrain is given as 7%. On hill road, the maximum super elevation is 10%, and on the urban road stretches with frequent intersection, it may be necessary to limit the maximum super elevation to 4%. Okay, so these are the different values of the super elevation. Now, what about the minimum super elevation? What should be the minimum super elevation? So, from drainage consideration, it is necessary to have a minimum cross slope to drain off the surface water, and for that reason, we have provided the camber. Now, if the calculated super elevation equal to or less than the camber of the road surface, then the minimum super elevation to be provided and horizontal curve may be limited to the camber of the surface. So, whatever camber is provided over there, you just provide the super elevation according to that camber. That is your minimum super elevation, and for the maximum super elevation, these are the values. So is it clear? Is it clear? Okay, if it is clear, you just go through all these things. Okay, so let me end the class. So you can leave the class.
What attendance?
Attendance, similarly, I will take based on the previous class, that is absent is 53, 55, 58, 59, 65, 78, 79, 80, 96, 104, 111, and 115.
Sir, 75.
Sir, 115 is present.
One by one.
Sir, 115 is present, sir.
Okay, 115 is present. Okay, and
75.
75, I have not considered. 75 is already present. Okay.
Sir, 53.
50, 53 is present. Okay.
Yes, sir.
Sir,
Okay.
80.
Sir, 69.
Sir, 63 is also present, sir.
63. Okay. I have also only told about 65. 63 is present. No.
Sir,
Okay.
69.
Sir,
59 or 69?
Present, sir. Present, sir.
59. 59.
69.
69. Okay. 69 is there present. 80. What about 80?
sir, 80, 80.
Okay.
Sir, present, sir.
Okay. Okay. 80 is present. Okay.
Okay, thank you, sir.
Anyone else? 121. 121.
Sir,
121 is there.
62, sir.
Okay. 61 is present.
Sir,
62,
84.
sir.
82 is also present.
Sir, 84.
84. 84 is also present.
Sir, 110 present.
Okay. 110 present. Okay. I have marked this in my previous class.
5.
Uh-huh.
85. 85.
85 is also present. I have
Sir, 62.
62 is also present. I have marked absent only for uh, uh, just a minute. Okay, that is 55.
Sir,
Uh,
roll number 80, sir. I was present in previous class, but due to
okay.
network problem, I didn't give attendance.
Oh, okay. I know about this.
The same thing happened
Okay, sir.
109.
Okay, okay. That's why I'm just collecting the roll number who will not be present for any classes. Some of you may have leave the college, na? So that's why I've taken these things. Okay, see, these are the roll numbers which are marked as absent.